Good morning, one and all present here. I, Sandeep Tuli, Assistant Professor, Department of Computer Engineering, Poornima Institute of Engineering and Technology, Jaipur, welcomes you again in the first session of the last day of this first short-term training program under AICTE AQIS on image processing and its application. Today is the last day of this workshop. Sixth day it means we have already conducted the sessions from last 5 days, and we are maintaining the attendance of each sessions online, and we will share the attendance with you after the STTP. Today we are having three sessions at 10 o'clock, at 11:45, and then last one is at 2 o'clock. At the end of the third session, we will throw a quiz to all of you, and that needs to be that is also that will also include some feedbacks of this STTP. You all need to attend that quiz. Then the certificate will be issued on the basis of the attendance. So at least 60% attendance is required from your side in all the sessions in this STTP. Based on the attendance and the quiz, we will give or distribute the certificates in coming days. So now we should start the first session of today's program. And in this session, we are going to have a discussion on edge detection methods along with some hands-on. And for this session, we have with us Mr. Saurabh Gupta. I welcome you, Saurabh sir, for this session. Mr. Saurabh Gupta, working as an assistant professor in the Department of Computer Science and Engineering, Poornima University, Jaipur. He has done his MTech and currently pursuing PhD from Indian Institute of Engineering Science and University, Jaipur, Kolkata. His research area includes machine learning, deep learning, and networking. He has total experience of 14 years, which includes teaching experience of 13 years and 1 year of industrial experience. He is also a Google Scholar and published paper in Scopus Index and international journals like IGPI Global. He also presented papers in IEEE conferences. He is also a member of many international conferences committees in Dubai, Australia, and India as well. So we welcome you, sir, and I request you to kindly enlighten us with your knowledge. And over to you, sir.
Thank you, Sandeep. Thank you very much. I'm very much thankful to Poornima Foundation for providing me such an opportunity to speak in front of eminent professors, students. So again, I am thankful to Poornima Foundation. Before starting today, I want to tell something that I have chalked out a plan in such a way so that the theoretical aspects are also seen in the practical concepts. Am I audible? So because you see, when we learn the theory, but if we don't see the practical implementation, we have a vague idea about that. We cannot understand the concept. So it is better to have a theory and as well as a lab session. So I have created that for you. Today I am going to talk about Gaussian blur and canny edge detection. So in machine learning, we use a package that is called OpenCV. Everybody who are working in this domain, machine learning, they know that this is very, very important, this OpenCV package. So here, today I am taking two dimensions. One is the Gaussian blur, another is the canny edge detection. So you know that nowadays, whatever image we are taking, that is consisting of high resolution images. So it is a RGB image, and RGB image is holding 3 channels. So RGB, you know. Anybody can tell me what is RGB? These are the 3 colors actually, RGB. Anybody? Any participant? Yes. So red, green, blue, yes. But what happens if you want to detect the edge? Today I am going to tell you about a particular hands-on experience where you can detect the edges. But to detect like canny edge detection, this Gaussian blur and canny edge detection, we are using this for detection of edges, because from the image I want to uh, generate something, some information. So I have an image but from an image, what information can I gain? That is my main motto in the image detection. So Gaussian edge blur and canny edge detection will help you to generate something new. So it is a part of, I tell you about the background of the project. Project is like this. I am driving a car, okay, and now the lanes are not clear to me because of maybe because of rainy season, because of foggy weather, because of some climatic change, I cannot see. So what I want to do in my in my car, I want to superimpose. So I am running with my car, so that is a video going on. That means, let us suppose that is a video. So if I superimpose a still image in front of me, so I can drive out that car. So that can restrict the accident, because it is a one-way lane, so there is no chance of collision. So first of all, I want to superimpose that image into that particular video frame. So video frame, I'm driving the car. So now you see, nowadays you can see that lots of research is going on how to land an aeroplane without a pilot. Now you know that nowadays pilots are manually landing and taking off the aeroplane, as well as we are driving the car, but there is a concept of driverless car also. So but in this type of situation where the upfront scenario is not clear, or you cannot visualize the front area, so how can you drive the car? So in that case, you have to detect the edges of the image. So if you can detect the images, so you can understand the boundary of the lane, and you can easily drive out the car. So this is the foundation of today's lab experiment. So first of all, you have to know what is these concepts. So basic steps involved in this algorithm is the noise reduction using Gaussian filter. So what happens in an image? Lots of noises are there. Noise here means, you can understand that many pixels are not clear, many pixels are hazy. So you want to make it more, you want to understand what are those pixels, because those pixels are not clear to you. So for that, we are using this Gaussian blur technique. So what happens with the Gaussian blur? We are many researchers have given many theories. Somebody has told, take the average neighboring 5 pixel values average and replace with the value if it is greater than that. Somebody has told that no, take the 3 neighbors average. So there is a pixel and there are 3 neighbors of that pixel. You take the average, and if it is greater than that, then don't replace. If it is less than that, then replace with the average value. So many researchers has given many theories, but it is up to the researchers which theory they will like, they will not like. So there are maybe many filters, like Gaussian filter is there, there is Sobel filter is there. So many filters are also available. So choice is up to you. When you do the simulation, when you run the coding into your Google Colabs and you run several epochs, then you realize which filter is working well for me, because we do not understand upfront that which filter is better, but because sometimes we cannot understand that which filter will be operating better. As we know that in deep learning, activation function, many activation functions are there. Which activation function you will use, sometimes it is not clear to me, though some research papers are guiding us that in this way we can do, in that, in this is the activation function I have used better. But again, the filter, what filter you will be using, what filter you will be applying into your application, that depends upon your experiment results which are coming. So here I have used the Gaussian filter. Many filters are there, you can find out through net. So as I've told you, Sobel filter, many researchers have told many about many filters. Filters are nothing, it is a matrix. As you know that image is nothing but a matrix. So if you think about that 2D image, so it is a matrix of rows and columns. If it is a 3D, it is a little bit typical. But now now we are handling only the 2D images. So the filter, Gaussian filter, we are applying on the image, and applying on the image, we are doing some permutation and combination, bitwise and bitwise or whatever operations we are doing. We are doing lots of operation on that, and after doing the operation, we are generating a particular image. So that image is telling us something new. It is giving some new information. Like you see that tumor detection. So tumor detection, if I give you one high resolution image, sometimes it is not possible to detect the tumor using the skeleton of the brain. But if I do some permutation and combination with filter, so permutation and combination with the standard filters, we may generate some information. So these are the various research topics along with the filters you can do, and these are the permutations and combinations filters are doing with the original images to generate some new information. This is the background. Now noise reduction, as I've told you, if we can reduce the noise, as the Gaussian filter is a 5x5 matrix. As you can see that Gaussian filter, if you look into Google, you can find out that Gaussian filter is a 5x5 matrix, and it will help you to reduce noise. And there is an equation for that, but generally for coding, equation is not required. For researchers, equations are required. So I am not going into the equation, because in practical implementations, equations are not required. It is only the function you have to call. So I am not going typically into the mathematical part, because it will create mental boredom for you. So just I am trying to make you understand in a very, very lucid way. Then there is a second part, is the gradient calculation. So gradient calculation, what is this concept of gradient calculation? You see that when we move from one portion of the image to other portion of the images, so suppose you convert the RGB image into grayscale. So there are only two things. One is the black, and another is the white. So once you convert the RGB image into 3-channel image into one channel, so RGB, so that means you from RGB you convert it to grayscale. Now once it is grayscaled, now there are two portions. One is the black portion, another is the white portion. Now why we are calculating this gradient? Because this will help us to understand the edges, because if there is a color change from black to white, we'll understand some edges there. So suppose your brain skeleton is there. If your brain skeleton is there, some portion, so the bone portion will act like suppose black portion. So obviously if there is a sudden change in the pixel value, you will understand you are going, or you are migrating from the 0 value to 255 value, or 255 value to 0 value. There are only two values. One is the white, another is the black. So that is very, very easier for us if we calculate if there is a sudden gradient change. So gradient is nothing but derivative. We apply a derivative function. If the derivative value becomes huge or large, then we understand there is an edge in that particular image. So that edge can be detected by using that gradient value. So that's why this gradient calculation is done. Now how this gradient calculation is done, just see one example I'm showing you. See this image. So 0 is suppose 0 is representing black and 255 is representing white. Now you see, if there is sudden change of value from 0 to 255, you understand there is edge. So where is the edge? Where the gradient has taken too large value. So that means a strong gradient indicates a steep change, whereas a small gradient represents a shallow change. So if there is small value 0 to 15, so it is not a proper edge. But proper edge is where you can find this color change is happening from black to white. But here you see there is a shallow change. So we cannot tell that it is a proper edge. So for detection of edge, this particular gradient calculation is very, very, very important. Now you may ask me the question, how to calculate the gradient. So gradient can be calculated vertically as well as horizontally. That is up to you. Means any direction you can calculate the gradient. You can calculate vertically also, you can calculate horizontally also, you can calculate both horizontal, vertical. So that is up to your research work, which combination works fine for you. So you see this ball. This was the original image. But what happened when we are calculating the gradient? You see the portions are representing the edges. So this particular ball, you can see these edges can be easily tracked by the gradient, because here From black, it is going into the white portion. So the edge is being detected. So that's why this gradient calculation, both horizontally and vertically, it is recommended you should calculate. Now you see, I'm coming again into the theory just I have shown you. So this is the gradient calculation. Now third point of this edge detection is non-maximum suppression. This step aims at reducing the duplicate merging pixel along the edges to make them uneven. So what happens, sometimes we have a common region, duplicate region. So I am comparing with 3 neighbor values, I am comparing with 5 neighbor values. So some particular values are coming again and again. So that should be reduced, because if common regions are coming again and again, that will create problem for my calculation or for my edge detection. So that particular theory is used for this purpose. Then double thresholding. Now you see, when we'll be doing hands-on, we'll be passing two threshold values, and one is the low threshold, another is the high threshold. So in the OpenCV package, when we'll be calling the OpenCV, we'll be passing two threshold values. So that will be done on the trial and error basis. So how to, you can ask me the question that how to select the threshold value. So threshold values, first of all, when you display image, the pixel values are generated. Now you see the pixel value, so you have a look about the pixel value. You can take into a numpy array, and then you can see what is the range of the pixel values. Now you decide about the low threshold and higher threshold. That will be decided by you. You may take, suppose I take 50, 150. So low threshold is 50 and higher threshold is 150. Based on the low threshold and higher threshold, I will be rejecting the edge or I will be accepting the edge. So that will be the criteria to accept or reject the edge. That's why I am taking this thresholding. That's why double thresholding. Then you see edge detection, as it happens in the image, we can see the intensity of the image changes. You see that from the black portion, now it has come to a white portion, and from white portion again it is changing to black portion. So that's means where the gradual or substantial changes is happening. So here we can find out the edge. So these circle portions are telling me that here is a particular change in the gradient value. So we are understanding it is an edge. Now you see what is happening. This is the image. So one portion was the black where 0 zeros were the pixel values. Now you can see that 255 is there. So that means we are understanding that 0 and this is the portion of the 255. That is the white portion we are seeing. Now in today's experiment, we'll be using, I have shared this test image where you can see the right hand side is holding RGB channel, and this particular image is holding only the grayscale. So I have converted this image into a grayscale image. Now this, if we visualize these two images side by side, we can find out a difference in between these two pixel values or in these two pictures. Now edge detection steps convert the image into grayscale, as I've told you, because if you work on the RGB channel, it is not good, because RGB channel will not help you to find out some information if you want to detect the edge. So for that you have to convert it into grayscale, where you minimize the 3 channel into 1 channel. Then you reduce the noise using Gaussian filter for smoothing of the image. Then you see, if I apply this particular matrix, 5 cross 5 matrix, so I do some permutation and combination with this particular image, it will generate some new information. What information I am wanting to generate today's project? See this lane is holding some white portions, white arrow portion, because you see that some portion are not clear. The road ahead is not giving us the clear picture about this white. So I want to make it very, very clear so that I can drive my car. So these informations here in this picture are not very much urgent for me, or this is not much of essential for me. The essential information is this particular portion, this particular polygon, this particular polygon area is my essential information. So that I want to find out, that particular area I want to chalk it out so that I can drive without any accident. Then you see that once it is blurred with the Gaussian filter, it smoothens your image. So some of the noise are reduced. So if you apply in different images, you can find out. You take one high resolution image and you apply Gaussian blur and you visualize, because it's part of the visualization. Once more and more you visualize, you will understand what is the main difference. You will find out that some of the things are getting very smoothened, which were not clear in the original picture, but after doing grayscaling, if you smoothen with the Gaussian blur, now it has become very, very clear to you. So what is this pixel? We can understand the pixel in this way, that we take a height and we take in a 2D image, we take a length and a breadth. So that means we take an X axis, we take a Y axis, and along with we'll process the information. And Kenny performs derivative to detect change of intensity. So why we are using Kenny function? To detect the change of intensity from 0 to 255, from 255 to 0. So that can be only detected by this derivative function, and that derivative function is used by Kenny edge detector. So you're seeing that 0 to 255, here it is going. So both here I have shown you in the horizontal way. You can also check it in the vertical way also. So in both ways you should check. If there is a sudden change in the vertical way, also there will be an edge. So the edge will come here also. So you have to both check vertically as well as horizontally. Now you see what I am trying to do here in my today's work. This is a lane, and I want to find out what is my region of interest. This is my region of interest. So if this portion of the lane is very, very clear to me, I can easily drive out the car, because I am understanding these are the edges of the roads. If edges of the roads are clear to me, I can easily drive out the car. Otherwise I will meet with an accident. Though it is a one lane, but I should understand the edges or border of the road. Otherwise I will meet with an accident. So that's why today I will try to demonstrate with the experiment that how we can detect the edges using Kenny edge detection, and how I can put into the scaling, and after doing scaling I will drive out the car. Now this lane is like a polygon. Some lanes may be square type, means it's going straight, there is no bends in that. So for that you can use square instead of polygons. Now you see what is being done by me. You see, this is the after smoothening of after converting the RGB into gray image, and from gray to convert into the Gaussian blur, I have smoothened the image, and then I have created this polygon, and this polygon is filled up with the white portion. So what is happening? So let us suppose, you see, you think about that this particular portion is all binary 1, because these are 255. You know that in digital electronics 255 is holding all the 1 values in all the digits. So it is a 1 portion, and black is 0. So if I do bitwise AND, if I do, listen carefully, if I do bitwise AND, what will happen? This is the original image, this white portion. So this is white, that is the 1. So all the digital ones are there. So 1, if we do AND with 1, so it will remain 1. So the edges are not changing. Here the edges are not changing because 1 is ANDed with 1. So 1, if we do bitwise AND operation of 1 with 1, it will generate 1. So the white portion is remaining white, but what is happening? The other pixel values which are having combination of 0 and 1, so 1 along with 0, If we do bitwise AND, it will become 0. So this particular portion, so that's why when we are doing with the after we have generated this polygon which is holding all the white values, and here we are having white values we are seeing. So this white portion is remaining white after bitwise AND, but all other values are going 0. That's why you are seeing that in this image no other images are coming. So that's why, because they have that white portion is reduced, because here the white portion is there, but I have taken only this masking area. This area I have masked, and after masking, what I have done bitwise and if I have done bitwise and this is my region of interest. So this is my region of interest. I am not taking into consideration any other area of the lane. I am only taking into consideration the road borders. So if I have created this polygon, and along with the polygon I have done bitwise AND. So it is now whenever I am getting that particular image, that will generate me a particular border area only, because other areas will be black to my camera, because I have done bitwise AND operation. Is it clear to everybody? Any confusion? If you have, you can ask me question. I am coming into the hands-on. So already I have shared one. So I am using actually the Anaconda Jupyter Notepad. So I am using Anaconda Cloud. You can see this is those who are using Anaconda, they know already. I have shared a drive link also. You can download later on, or you can use Google Colab. So if you launch the Jupyter Notepad from here, it will be launched. So I am using this. So in the Jupyter Notepad, what is the prerequisite for doing this experiment? First of all, you have to install a package that is called OpenCV. Conda install. I'm just Conda install -c conda.forge OpenCV. But doing this, sometimes it generates error because of your upgradation of kernel. Sometimes upgradation of kernel is required, because here you see I am importing CV2. So CV2 is the second version of the OpenCV. First of all, OpenCV came into market later on. Now new versions are coming. So maybe your kernel is outdated and you have to update your kernel. That's why you need to upgrade your kernel. Once you upgrade this kernel, and then again you open the Jupyter Notepad and you run import CV2, import numpy as np, it will run. Otherwise in Google Colabs it will automatically run. Now in the second cell, what I've written, image is equal to cv2.imread test image.jpg. So I have taken that image and I'm running. And now I am using that ImShow function. So CV2 has a inbuilt function. You don't have to do anything. You have to write CV2 dash dot. So if you write, suppose I'm writing dot, let us see, IM, you write, then press a tab. Just you write IM. You don't have to remember the total function dot IM and then press a tab. It will show you all the listing of functions. So ImShow will appear, and in the ImShow, what I have written, result, I have given a name of the image and I have passed the image which I have taken into account. Then I've used cv2.waitKey0. So this is very much required, because if you don't give wait key, it will not be halting. The image will not be halting. So there is a signal value is required. Now you can see that I am using this wait key function. Why I am using this wait key function? Because if you don't give this wait key function, the image will not be halting. So this wait key will halt the image for several seconds until and unless you press any key button from your keyboard. So that's why this is required, wait key. Now, after I run this, suppose first of all, first cell I run, second cell also I run. So it is displaying the image. Now, next portion I am going. Image is equal to cv2.imread test image.jpg. I have passed. Then lane image. So what I am writing, lane image is equal to np.copy. You may tell me that why I have not written lane image is equal to image. So what will happen whenever I am passing a copy of the image to any other variable or any other object. So if I do some changes, it will affect the original image. It happens. That is a problem of the Python, because that will affect the original image. So that's why it is better, always recommended, you create that np.copy. The NumPy has given you the facility that it will generate a copy of the image, so that if you do some changes in the lane image, the main image is not hampered or nothing is being done in the main image. So that's why I have taken np.copy. Otherwise you can take lane image is equal to image, it will copy pixel by pixel all the things, but it is recommended that you use np.copy. Then what I have written, I want to convert into a grayscale. So there is a concept cv2, there is a function that cvt color, that is convert color. So what I have passed, I am not hampering the original image, I am passing the lane image which I have copied using np.copy. Then I am writing comma cv2.color to color RGB to gray. So this is an inbuilt function in cv2. So I am passing convert in the cvt color RGB to gray function. Then I am using cv2.imshow. Then I am giving the name of the result as a result, and then I am passing gray, that gray function, that is the gray what I have done. So let us see. So you see that original image is converted into a gray color image. So from three channels, it has become one channel image. Now, in the next portion, what I am doing is I am using Gaussian blur. So what I am writing, that image is equal to cv2.imread. So I have read that the same concept I have used, lane image is equal to np.copy image, gray is equal to, so gray scaling first of all I do, so that I've already done, but again I am doing, because in each and every cell how I am increasing my coding, that I am showing. In each cell you will see that my coding is being implemented from the last one. So cv2.cvt color, so already RGB to gray. Then I'm using blur is equal to cv2.gaussian blur, and Gaussian blur passed the gray image and along with 5,5, and 0 means standard deviation is 0, deviation is 0. Actually 0 means deviation is 0. Now 5,5 is the matrix which will be working with, or which will be doing some permutation combination with the grayscale image, and it will be generating one resultant image for us. So that's why I am passing, along with gray, I am passing my Gaussian blur matrix, that is 5,5, and deviation is 0. So that deviation you can change, that is up to you. If you do more research on this, you will come to know how deviation you can change, but that is a part of study, further study. So for the timing, we keep it as deviation as 0. cv2.imshow, then I am giving the name of the result as a result, and then blur. Then let us see what is generated. Now you see that from the grayscale image, the image is being little bit smoothened. So if you do more and more experiment with your image, you will understand what are the portions. If you look carefully, very carefully, some of the portions will be smoothened, which was not clear in a grayscale image. Now the next portion, I am using this canny function. Let us see what I have written here. The other portions are same, but here I have written canny is equal to cv2 dot canny blur. Then I have written that 50, 150. So these are, I have discussed in the theory that there is a low threshold value and there is a high threshold value. So that threshold value I have given. Why? To detect the age. Because suppose if the image values, your pixel, neighboring pixel values are lying between 50 to 150, it will remain intact. Otherwise, it will be black, something like that concept. So there is a low threshold, there is a high threshold, and that is decided by researchers. When you do permutation combination, now you have seen the matrix of the image. Now you understand that I should fix up this particular as the low threshold, this particular value as the high threshold. You take the average of the pixel values, then you decide about the low threshold and high threshold. Because low threshold and high threshold we are deciding so that we are not taking into consideration all the pixel values, only the pixel values which are coming under this 50 and 150 we are taking into consideration. So you see, from that image which we have taken, so first of all the original image was converted into grayscale image, and from grayscale image we have smoothened the image using Gaussian blur, and from smoothing now we have understood the edges of the images. Now the edges are very clear. Now you see, when you are driving a car, your region of interest is this, not the mountains nor the trees. So these are not your region of interest. Your region of interest is this one, because you are driving here only, you are driving here only, you are driving here only. So this is the portion you are driving, and your region of interest is only this particular polygon. As I've told you, here in this experiment I have used polygon. You may use square. There are lots of functions available. Square also you can use. If it is a straightforward lane, you can use a square function also. But as we know that generally that lanes are zigzag, lanes are not very means always the straight lanes. But in case of national highway, you can use a square function also. So in your experiment, you can use square function and you can have a look, but the concept will remain the same. Now, after, so I think up till this portion is clear. Okay, I think there is no doubt. Now, what we are doing here, you see, after we have applied, now what we are doing, we are writing a function of the Kenny. So why we are writing this function? Because we want to put it in a scale, because I want to understand that this image is covered by which scale. So if I put a scale, I will understand the boundaries of my region of interest. So my region of interest is this. So for that I have to know the pixel values. So both in the x direction and in the y direction, I should understand the pixel values. If I understand the pixel values, I can easily understand how to cut the image, because I will not take into consideration the mountain portion, these houses, these trees. I will only take into consideration this lane. So that's why what I am doing here, there is a package, you know already, those who are using Python, there is a package called matplotlib. So we write that import matplotlib.pyplot as plt. We are creating an object of the matplotlib and the pyplot, which is under matplotlib. Then we are defining def Kenny. So this is the way in Python to define a function. We are passing the image as parameter. Then we are writing, so the same function we have written, I have not changed anything. Gray is equal to cv2 dot cvt color. Then I have passed the image and cv2 dot color underscore rgb2 gray. Kernel is, now I have taken a variable, you may take, you may not take, you may pass directly 5,5. I have passed kernel is equal to 5, and then I have passed kernel comma kernel. You may directly pass 5,5. There is no requirement of defining this variable, but I have taken this. Then blur is equal to cv2 dot Gaussian blur. Then I have written that gray kernel comma kernel. So that is the gray 5,5 that I have told you, and with the deviation 0. I am not taking into consideration any deviation function on any deviation. Only I am taking the concrete 5 cross 5. No deviation I am taking into consideration. Canny is equal to cv2 dot canny. Then I am writing in bracket gray comma 50. So there is a low threshold, and 150 is the higher threshold value. Then I am returning Kenny. So I have written return Kenny. Now I'm writing image. Image is equal to cv2 dot imread in bracket test image dot jpg. Then I'm creating copy of the image np dot copy bracket image. Then I'm writing can is equal to can lane image. So I have passed into that. Now I have used PLT. So the object I have created of matplotlib.py plot, the object I have created as PLT. So that PLT dot, there is a function of that object which is supported by this matplotlib and py plot. So the function is IAMShow. So IAMShow, I'm writing Kenny, then PLT dot show. So it will show you. So see, you are also using previously with the CV2. So CV2, you see this concentrate on this region, CV2 dot IAMShow. So you may ask me the question that why you are then using, instead of cv2.imshow, you are using plt.show. Why? Because this plt.show is helping me to understand the pixel values. Here you see 0 to 700, 0 to 1200, that is being plotted. Now you can understand, if I want to select the boundaries of the image, it will help me out. Otherwise, it is not possible to understand the boundaries of this lane, because I want to chalk out this particular region. That's why this scaling is required, and this scaling will not be given by your cv2.imshow function. That will be given by PLT. That's why I have used here matplotlib. So a good data scientist or good researchers will use those functions which are helpful at that moment, because here I have found out that cv2.imshow is not helpful for me. So that's why I have used matplotlib and plt.show. So now the boundaries are very clear for me. Now how I will chalk out a plan to cut my region of interest. Now in the next portion, you see import numpy as np. Then I've written that def canny in bracket image. So I passed out that particular parameter. Then gray is equal to the same thing I've written, Gaussian blur, then canny, low threshold, high threshold, return canny, the same. Now the extra function I have used here is the region of interest. So where lies my region of interest, I have to find out now from the scaling. So I have passed out the parameter as image. Height is equal to, I have written image dot shape, then I passed out 0. So you may ask me that why? Because if you see, if you pass this save function in a 2D image, there are two things. One is the row, another is the column. So you see these rows are representing different columns. So these 0 to 200, suppose one column, 200 to 400 another column, 400 to 600 another column, 600 to 800 another column, and these the y-axis, these are representing 0 to 100 one row, 100 to 200 another row, 300 to 400 another row. In this way, though we understand that this is the column, y-axis is for column and x-axis is for row, but here little bit of difference is there. What is the difference we are having? The difference is we are thinking that this y-axis is acting as row, because 0 to 100 we can take into consideration one row, 100 to 200 another row, 200 to 300. It will be helping me to understand the row boundaries here. So that's why I have taken here, the concept is like that. In that way I have utilized that concept, that shape 0. So shape 0 means there is a y-axis. Y-axis here we are representing in rows. Now we are writing polygons is equal to np.array. So you know there is a list function in Python. Those who are doing Python, that they know that there is a list concept is there. So in the array np.array, I am passing this list. What list I am passing? 200 comma height. So three pixel values I am giving: 200 comma height, then 1100 comma height, then 550, 250. Now why we are giving this in the polygon? So this polygon I am creating in this way. So three pixel values are taken. Now let us see. If you see, So height is your this 700. So height means this is the maximum height I am taking. So actually the values are coming in this way, upper direction to lower direction, and here it is going in this way, 0 to 1200. It is being plotted like this. So I have taken my region of interest from starting from 200 and height means the 700, because I have passed out height is equal to shape 0. Shape 0 means the 700 maximum value will be taken. So I have taken this particular, suppose I am driving here, so 200, from 200 to this particular position I have to go. Now what I have passed 1100, so you see that 1100, so you can take 1000 also, that is up to you, because my boundary of the lane is coming in the 1000. So I have taken a little bit more, 1100. You can take 980, you can take 990, that is up to you. You can also increase here, you can take from 150 also. So for the sample I have taken 200. So my region of interest is from 200 to this portion, from this portion to this particular portion. I am thinking about in this way. So then I have written 550 comma 250. Now you see 550 comma 250. So 550, let us consider 550 comma 250. So let us come into this portion. Now this particular portion I want to check up to which portion I want to take. So let us suppose this portion I am taking. So this particular where the lane is ending. So 250. So here is the 250. If you chalk out the y-axis, this is the region 250, between 200 to 300. It may be 280, it may be 260, but I have taken 250. And this portion now you take into the x-axis, so it is 550. So almost 550, it is like that. So you may take 580, you may take 560. So I have taken 550. So my region of interest is from here to here and from here to here, so that I can understand my boundary or my lane. So you may take from here also 150 also, that is up to you. Now once I have taken this region of interest, once I have chalked out this polygon area, now what I am doing, I am passing, I am now there is a, I am passing into the variable mask. Mask is equal to np dot zeros like image. So I am filling this area with the zero values. I am filling this area with the zero values. And then what I am writing, the cv2 dot fill poly. So I am filling this particular area with the polygons. So this masked area, whatever I have taken, these polygons, the polygon area, that polygon is filled into the mask area. So mask is 0, where 0 values are there only, and I am filling these 0 values with the polygon, which area. So let us see, if I run this particular code, you see that this particular portion is coming. So that means this particular polygon which I have chalked out or I have planned out using the scaling of PLT, matplotlib.plt. So seeing the scaling of PLT, I have chalked out and I have filled out my region of interest. So this is my region of interest I have taken into account for the time being. So that's why these pixel values I have given, because these pixel values, if you see, that will create the boundary of the polygon. And at last here we are seeing that we are passing again. So after, so we return the mask. So what we are returning ultimately, the mask we are returning. And then image is equal to cv2 dot I am read, that I have already read. Then I am showing the region of interest. What I am passing now, I am passing the region of interest in the bracket Canny. So the Canny image which I have used, that I have passed in the region of interest. And what is my region of interest function, that I have already defined, that with the pixel values I have chalked out my region of interest. Now the last portion, we are seeing that after we have chalked out the region of interest, what we have to do actually, we have to do a bitwise AND operation. As I have told you in the theory, that why bitwise AND is required, because if the region of interest is white and lane is also white, so your polygon is holding a white area and your lane is also white, so because that border areas are white, suppose, okay, so your that arrow, the road arrow, those are white. So if we do bitwise AND with 1 with 1, it will generate 1. So that means the border area will not change, other portions will become black. So that is my my area of interest is generated. So my main motto is to generate the area of interest using bitwise AND, because the white portion in the original image, that is also white portion, because the arrows are there, road arrows, suppose, let us suppose the road arrows are white portion, and your polygon which you have filled, that is holding also the white values. So what is happening? One bitwise AND operation of 1 with 1, so that means the edges are holding. So if the edges are holding, that is the job done for me. So I am trying to find out my lane, my region of interest, so that I can drive my car. So my things are done in this way. So what I am trying to do here, import numpy as np, then def canny image, then I'm writing gray is equal to cv2, that we have already done graying, then blur we have done, then canny function we have done, then we have returned canny. Then def region of interest image here. Now you see that what we are using here, we are using extra function here, the masked image. Now I have taken a variable or object where what I am taking, cv2 dot bitwise AND. Now I am doing bitwise AND operation of image along with the mask. So what was there in the image? So let it be very clear. So this was the polygon we have generated. So this polygon will be doing bitwise AND operation with the image. So image means it is not the image, it is the canny image. The that means that we have done already RGB to gray, and after applying Gaussian blur, it is being smoothened. And with that image, I will do bitwise AND operation of this. So that canny already we have done. This is the coding for that, Gaussian blur and then canny we have done. So if we do bitwise AND operation of the image, that is the after doing the canny operation, and along with the mask we have created what np dot zeros like. So we have filled the polygon with the zeros. Then we are returning the masked image. So after doing the bitwise AND operation, we are returning the image. So what we are doing here, again image is equal to cv2 dot imread test image dot jpg, lane image np.copy image. As I've told you, don't tamper with the original image, always take the copy of the image, because otherwise if you create many if you copy the main image into the other images, if you do some pixel value changes in those images, the original image will also change. That happens in Python. That is the drawback, because it will not create the separate copy, it will be affecting the mother copy also. That happened, I have seen, because when I was doing one project, I was not understanding that I have copied the image, still why the pixel values are changing. The researchers will be having tremendous trouble here, because they are understanding that I have only copied, but the pixel values are changing, because you are changing the way you have copied. Now in the copied image you are doing some operation, and if you are doing some operation, the original image is also getting changed. So that is the biggest loss we'll be having. That's why the numpy array has given you the facility that np.copy you use. Then after doing this copy, then we are passing canny is equal to canny lane image. Now what we are passing, region of interest canny. So that I have already defined in the region of interest. What modification I have done? I have done this particular modification, that is the bitwise AND operation of the canny canny edge detected image along with the mask. That mask is nothing but the polygon which is holding all the zeros. Then I am running this function. Now you see that your area of interest, so your area of interest in the lane was your road, not the mountains here, not the houses here, not any other things. Now you are able to understand what is your area of interest and where to drive the car. So it is a foggy, though it is a foggy season, though it is a suppose rainy season, you are able to understand that what is my region of interest. So actually it is a big project where what happens when you're driving the car. So it is the video that is going on. So that project, it is not possible to show you the total project, but because it will take more and more concepts, and it will take more and more time, because it requires another 2-3 hours to complete that project. Where you're driving, I have a video where you are driving a car, and suppose that car, now you can detect that where you are using GPS. So you are actually in the video motion, but still image you have. A priori you have a still image, and with the still image you can superimpose on your driving, and you can understand what is your region of interest, and you can drive away your car. So these are the projects that is happening, and many people are trying to do disaster management in this using this driverless car. So what happens, I will superimpose this still image while you are driving. So your upfront area, now as I have got the clear cut region of interest, so your upfront area will be clear for you. So it will be helping you to drive your car easily without having proper revision. So this is a driverless project actually, but using canny edge detection, you can easily find out your region of interest. So I will request all the participants that you take this coding. I will share with Sandeep sir, Sandeep Tuli sir. So you take your own image and you try to find out your region of interest, whether it is a human skeleton, whether it, anything you are wanting to find. And instead of polygons, you may use square function, and many other functions are there where you can find out your region of interest. But the main concept is you have to first of all convert it to grayscale, and from grayscale you have to do blurring, and blurring you may use any technique. Instead of Gaussian blur, you can go for any other blurring technique. Many techniques are there, and then you can use canny edge detection technique to understand your region of interest, and then you can use this bitwise. And as I've told you, in this project there is a bitwise, and you may take any operation. There is no harm using any operation, because that depends upon the project which operation you will take. It is not that always you will do bitwise and you can do any operation according to your need. You will do your operation, but the concept will remain like this. Coding is clear? Any participant?
Good morning, sir.
Good morning.
Sir, I have a little query. Can I ask at this moment?
Yes, yes.
Sir, suppose if there is a zigzag position, suppose, so then what you will suggest? Any function or any idea? Can you
No.
provide?
In case of zigzag position, you have to first of all visualize the upfront area. Means suppose it is not that the total area is zigzag. Up to a particular portion it is zigzag. That's why the projects are running. It is not totally implemented, but people are trying to implement this project, because if it is a totally zigzag, then you have to take one region at a time. So you, for example, you think of the 500 meter, you have to consider the first 500 meters, and after that turn is there. Then you have to consider from that onward, that area onward, another 500 meter. You have to consider in that way. But if it is a little bit of smooth area, and after that some zigzag happens, so you can take 1 kilometer at a time or 2 kilometers. That your GPS will tell you that up to which portion there is a turn. So you can understand that turn is there. So up to this portion you can apply. But in real time, as you are telling, it is a very difficult to superimpose and to apply that. And the hardware simulation, whether there is a challenge of hardware simulation of that. So researchers are trying to implement, though you can see that driverless car has been implemented, but it is not 100%. We can tell that it is 100% done.
Okay, thank you, sir.
Sensors are there. Sensors will help you. Various sensors are there. Sensors will also help you to understand any in between any problem is there or turn is there. So sensors, any something is coming in between you and the road. So sensors they are using also. So that is part of electronics and all these things, because computer science people does not understand about that, because we do not understand about the hardware things, because it's very difficult to understand the hardware. We can implement into software, but hardware, how it will be implemented, that is decided by the electronics engineer. And for that, they have lots of technologies for that.
All right, sir. Thank you.
Any other? A total project I have with me, where I have superimposed the still image into the videos, so that I can also share that coding. That is a big project. That's why I'm not taking it, because I know that only 1 hour 30 minutes, and you are already attending for 6 days, I think. So it is not possible to implement the total code. It will take 3-4 hours more. There's lots of how concept is there, how line concept is there. So lots of things are there. More than one image. Yes, obviously you can write. In research, there is no boundaries. You can write in this way. Means whatever you are asking, that more than one code for more than one. Yes, obviously that is up to you. Suppose you have taken for one portion of the image, you have taken Gaussian blur. For another portion of the image, you have taken any other blurring technique. You can take into account. That is, research is open to all these things. There is no boundary on that you cannot apply this filter, that filter, because see sir, filter, see madam, filter when we apply, we also do not understand that in deep learning networks, because you know that hidden layers are there. So 64 hidden layers you are using, so which filter will be working fine after the simulation result only we can tell. But through research papers we can understand that these are the filters, if we apply it will be working well. But you never know that one particular filter what the researchers have told, and you suddenly found out that this particular filter is working well for this particular application. That may also happen. So you have to do try and error. You have to do with the trial and error method in deep learning, and it will, the simulation will take more and more time, because as you are seeing, it's a machine learning. But in case of deep learning, what will happen? The hidden layers, it will automatically teach itself, because always we know that it is better to use hidden layers rather than applying machine learning. So if you go for deep learning, it will take more and more time to realize the simulation results. Then you have to see the parameters which are coming in between the simulations, and how parameters are happening, or how parameter results are coming, and accordingly you have to see the results and you have to find out, and which is taking more time. You will be using activation functions there. So many activation functions are there. Adam is there, sigmoid is there, then setmax is there, lots of sgd is there. So you'll, after applying the different activation functions, you will find out your results, and you have to analyze that which result is working. But for that you have to have the support of GPU. So Google Colabs will help you, but in some cases Google Colabs also will not help you, because you must have the access of supercomputer for that, because Google Colabs has its own limitation. There is a particular time limit for that you can use, or either you can go for Microsoft Azure framework. But again, there is a problem that in Azure, there is a pay-as-you-go service. So there is a cloud platform here you can use. 64 GB machines are also there. So, but the problem is you have to go for the pay-as-you-go service, and their bill comes, lots of bill comes. So if your university or any other institute have this facility to use Microsoft Azure and use that virtual machine, you can experiment your result in the virtual machine also. But the organization should support you, or you can take remote support from any other institutes when you are doing the simulation. Yes, the code becomes too late. You know, madam, what happens? Code is okay. Code actually machine code, it does not take much time. But the problem is if you are training 1 lakh of images, and it is a high resolution image, and see you are using 64 layer hidden layer, so you can understand how many epochs. So suppose you are using a batch size of 125. Generally what we do in the deep learning, we take a batch size, and in batches we do the training, we do the epochs. So you see 1 lakh image and batch size is 125. So how many training you have to do, and after that each hidden layer will have how many epochs, iterations. So you can understand the timing. So that is the main problem, that it will take more and more time for training, and for that supercomputer access is there. As Poornima is having tie-up with Bennett University, Poornima has the facility that their teachers and their faculties or their students can access the supercomputers of Bennett University, where supercomputer is there. But many organizations may not have these supercomputers because it costs around 1.5 crore, that supercomputer. So that's why we cannot write research papers, because for writing research papers minimum of 50 to 100 epochs are required, iterations you have to do, and in your machines it will not run. Your machine will just hit up and it will, the ICs will be damaged. That is the biggest challenge in deep learning. But if your organization or any industry supports you, you can easily do, and you can easily publish many papers, because those experiments results will be on your data set, and that data set is unique, and your results will come unique, will give you unique results, and that will help you ultimately to publish a research. Your results will be unique, it will not be matching with anyone. Generally what we do, we write research papers taking into account his research paper, her research paper, then we mix up the research papers, and then we tell that this is the result. But if you have the supercomputer access, you can train, you can do on your requirement, you do the iterations, you run the epochs, you take several types of neural network, 32, 64 bit, 64 hidden layers, and accordingly your results will come, and that will be unique results. So proper observations will be there. That is a challenge, madam. That is a challenge. So that's why today I have shown using machine learning, but you can apply this technique into deep learning. But the hidden layers you cannot apply in your machine or with your Google Colabs. It is not possible. If number of images are huge, that is not possible. That is the challenge. The main Ankur, the main challenge is, if, as I've told you, if your data set is too huge, like image for image, like nowadays you are purchasing a mobile phone, you see the resolution of the image, one image is holding several MBs. So if you have for training, for research, you will take lots of images. It's not that you will experiment with 500 images or 100 images. If you take, suppose, a data set of 1 lakh images, suppose, so it will be very, very difficult for you to train. How you will train in Google Colabs? So that will be a difficult situation for you. But if you have a supercomputer access 24/7, you run it, and now Google Colabs will run. And how, for how many days you will run your internet? Because you are running mobile internet. So suppose it will take 5 days, 7 days, 10 days. Is it possible for you to open your laptop for 7 days and retain your laptop in a AC environment, and also to run unlimited, means for say 7 days, 10 days, you have to uninterruptedly run your laptop. So that may damage, because if you are not having i7 9th generation like laptop, then it will damage your hardware also, because unlimitedly you are accessing your laptop, and it is doing in the Google collapse it is happening, but still in home we know that some problems of electricity may happen. Electricity happens problems, sometimes electricity goes away, so 10 days of uninterrupted service, it will be very difficult. But if some institution is using supercomputer, I have gone to Bennett University, they are holding a rack and they are holding in a proper environment, there is no interruption of power supply. So anytime you do experiment, 10 days, 15 days, any time duration you do experiment, it will be working. So that type of uninterrupted service you require in case of some unique work. But as we Indians are doing, we are mixing several papers and then we are publishing. So this is not our observation actually. Thank you. Thank you, madam. If any other doubts are there, so these are the technical problems of deep learning. So you have to arrange, somewhere you have to arrange these things. Now many people are arranging, many people are having remote access, they can do it. Sir, why blurring is done before? Because you see, smoothing is done. If you don't smoothen the image, it will be very difficult to detect the edges. Because what we do in the grayscale, obviously grayscale will give you, once you do some experiments, you convert some RGB image to grayscale image. If you find out some noise effect is there, the image is not very clear to you. Means some of the portions will not be clear. Obviously the edges will come in the, if you ask me that if you convert RGB to gray, obviously it's a black and white portion, some portions will be clear obviously, but some portion will see some pixels are coming and hazy portions are there, which will not help us to understand that particular portion. Like brain tumor analysis you are doing, so it will not be clear, some of the portions of the brain will not be clear in the grayscale. But once you smoothen, and then if you apply canny edge detection, it will be very clear. That's why we have to smoothen the image. That means we have to reduce the noise, because you see noise, why noise happens, like you do suppression, so MPEG, so you are suppressing actually, so if you are suppressing, some noise effect will be there obviously. So that noise effect has to be, why GPEG these are more popular, because they are suppressing, still it is a better quality. So that you have to come up with a solution. So only by converting RGB to gray will not give you the solution. Some of the portions will be hazy till more and more pixels are coming in one place, so you are not able to understand what this is. But if you smoothen that image using Gaussian blur or any other blurring technique, that portion will become clear. That's why we do Gaussian blur technique. Okay, thank you to everybody.
Yes.
Okay, my
Someone is
email.
asking for your email ID.
Okay, I am sharing.
So he or me, he may contact you later on.
Okay, no problem. Regarding the total project, I am sharing my number also.
Yes, sir, definitely.
Regarding the total project, I will help you. This is my WhatsApp number, which I have shared. Thank you.
Sir has shared his number as well as email ID on the chat box. So if anyone has any doubt now or in future, then they can contact them for their queries, for their research doubts. So now I would like to thank you very much, sir. Thanks a lot for this great session. On the behalf of the Poornima family and on the behalf of this organizing committee of the STTP, I would like to thank you again for this enlightened session. And I hope that all the participants has definitely gained something from this session. And like if they have any query, then they will ask like in future. Thanks to you, sir, and
Thank
thanks to all the participants also